Okay, welcome to networking. Welcome to networking. So our first thing to note here is to ask ourselves, what is a network? Then from there, we shall be in a position to look at what is computer networking. So when you talk about a network, it is just interlinking. It is an interconnection of network. And so it is a collection of computers linked together using transmission media for the purpose of communication and resource sharing. As simple as that. So whenever you interconnect gadgets with the purpose of data communication, then you have a network. Whereas data communication, this is the process of transmitting data signals from one point to another through a network. You see now again the term network comes in. We have terminologies that are very crucial and cannot be ignored as far as data communication is concerned. We have the bandwidth. The bandwidth is the maximum amount of data that transmission media can carry. So you hear somebody talking of 100 Mbps, 100 wherever such. Now, when you talk about gigabytes per second, megabytes per second, we are talking about the kind of data, the amount of data. Then we have baseband. Whenever you hear the word baseband signal, that is a digital signal. When you hear broadband, that is analog signal. Those are the key terms that are checked. Then we have attenuation. You realize that when signal is moving along a transmission media, it loses strength. That is attenuation. It is the process of or a situation whereby the gadget loses strength as distance increases. In that case, we need a booster or an amplifier called a repeater. Then we have signal modulation. When you are sending data, you may convert it from analog to digital because of a certain reason, then digital to analog. That one is called modulation. Modulation using a gadget called modem. Modulation, demodulation, modem. Then we have data signal. Data signal is the current. It is the voltage that passes current data. That is the one. Then we have multiplexing. You notice a situation whereby you have so many signals to send. Let's say you have 10 signals, and then they should be received by 10 recipients. Rather than having 10 gadgets sending 10 signals, you have one gadget converging all the 10 signals, sending them in one transmission line. Then on the other end, the signal is separated towards different addresses. That's how the booster, the one you call booster, works. So that one is a multiplexer and demultiplexer. So multiplexing is that process of converging and then separating the signals on their destination. Then we have modes of data transmission. We have simplex, half duplex, and full duplex. Now, look at a situation whereby you are watching a television or listening to a radio. You cannot answer that person. That is one way or one direction transmission of data. That is called simplex. On the other hand, you can take a situation whereby two policemen are communicating. One talks, says over, then the other one takes. That is the walkie-talkie. That is half duplex. It is sending signal in two directions, but one at a time. Then we have tunatumia na mobile phone. We have full duplex, a situation whereby both of you, both of you can transmit. It's transmitting data simultaneously in both directions. That is full duplex. We have types of networks. We usually have several types of networks, but we classify them into three. We have LAN, local area network. We have MAN, metropolitan area network. We have WAN, wide area network. The difference is local. Local means something very small, something kule kwa ushago kule ndani. Local means limited connection. It is a network within a small area, like a building. Metropolitan is a network within a town or a city, can span to 50 kilometers. Then you have this one that is worldwide. This is called now, it covers a long coverage. That is the world area network. Now remember, computer networking refers to a collection of independent entities that are arranged in such a manner as to exchange data, information, or resources. That is a MAQ. Purpose of networking. Now, purpose of networking, umuhimu wa ku-network stuff. Number one is resource sharing. Some gadgets are very expensive, like a printer. It may go up to $1 million. Now, instead of buying every class or every office a printer worth $1 million, you can have one printer shared by the whole school or by the whole bank. You send your document at the Gov, you work for it. That is resource sharing. It is actually making one gadget that's available for many people. So it saves on cost. Then you also have remote communication. You can send each other emails rather than now moving from one place to the other. So this involves devices located at different geographical location. But now instead of now taking a vehicle, going for a document in a certain town, you can just have it locally, remotely, using an email or WhatsApp or Telegram. Cost effectiveness, that one I've explained in the other side. You don't need to buy so much resources. Distributed processing, you may notice a situation whereby, take a situation of an ATM. The headquarters is in Nairobi, let's say, and then you have an Equity ATM in Kisumu, in Mombasa, in Kakamega, in Bungoma, in Nakuru. They are processing data in the headquarters rather than now being in one geographical location. You can subdivide data and then everybody can work. Also, take a situation whereby teachers are filling marks using their mobile phone, and this marks goes to the server, and then the dean or the head teacher can see the marks from one point. Reliability, if one site fails in a computer network, you will use the other one. So the network goes that way. So the limitation, these are the disadvantages. It is very expensive to install. People may hack or steal data, that is data security. Network failure, stima ikipotea, power goes off. Network failure, you may be over-reliant. That is over-reliance of the network. When you get used to the network, when it is not there, you get sick. Moral and cultural effects, people may watch pornography and other sites. Elements of networking. Components rather. What are the components of a network? For a network to exist, what is there? Number one is the media. That is the cables, wireless technology. Then you have communication devices. Even if you have boosters, you have Wi-Fi, and you don't have a laptop, and you don't have a mobile phone, that is the communication devices. You cannot communicate. Then you have the networking software inside your phone, inside your mobile phone, your laptop, inside your computer, inside your tablet. There is a software installed there. Something like Mozilla Firefox, Google Chrome, Opera Mini. They have been installed there to assist you communicate through now the data communication media. But whatever is exchanged there is called data signal. So we have data communication media, we have communication devices, we have networking software, and also we have the data signal that passes there. Let's go one-on-one on data communication media. It is categorized into two. We have wireless and keyboard. Watu wengine wanasema bounded or unbounded. It depends on you. For me, I would go for keyboard, and wireless. That one is easy to remember. So when we talk about communication media, keyboard or bounded, we have two wire open lines. I'll show you the images later on. We have twisted pair cable, we have coaxial, and fiber optic. Fiber optic is the current one. Then we have wireless communication, where we have microwave, we have satellite, we have Bluetooth, radio, infrared. Like now when you're changing channels using your remote, kwa TV, it uses the infrared. Then we have radio transmission, the way our radio works. Microwave and satellite, this one uses the space devices. So don't forget, we classify them according to that is keyboard, bounded and unbounded or wireless. Now this is an example of a two-wire open line cable. They are made up of two parallel copper wires separated by a plastic insulator, as the figure below. They are used in telecommunication network to transmit voice. You can see the way the two-wire open line cable looks like. We have twisted pair cable, very useful. This consists of two insulated copper wire twisted in a spiral pattern to minimize electromagnetic interference or noise. We call it electromagnetic noise. So we have the unshielded and shielded, just like the word goes. One is shielded, the other one is not shielded. And for that case, the one that is unshielded is prone to electromagnetic noise or interference, EMI. So you can look at this one. This one is used in our internet connections in our schools and institutions. This is called unshielded twisted pair cable. They do not have a shield that prevents electromagnetic interference. Hence, they are susceptible to noise and signal interference. That one can be asked in an exam. Then you have the shielded twisted pair, STP. They have a braid. They have a braid wrapped around the wire to shield or protect them from noise. You can see the photo or the image there. Then we have the category of twisted power cable. We have number 1 up to 5. It gives you the speed, voice, data. The other ones are used to carry the data. Then we have advantages and disadvantages. I have mentioned them when I am explaining. Then kuna ile wire ya TV, the wire that is used to connect the TV antennae ama aerial, munaita aerial. That one is called coaxial cable. This cable has a central copper wire or copper core, which may be solid or stranded wire surrounded by an insulator. The insulator is then surrounded by a hollow mesh conductor covered by a shield. Now, instead of so many explanations, you can just look at it. Then you can be in a position to draw or explain. So these are samples of coaxial wire. The one on your right hand side is very common. The other one is not very common. So it usually have the thicknet plastic jacket. It usually have the important part here is now the metallic shield and the center core. You can see it has the directive insulator. The other one also have the foil. This is very common. Karatasi yenye ina shine. Usually you have the foil, inner core, insulator. These are the coaxial cable. Make sure you can differentiate them in an exam or even in a real life situation. For the disadvantages and the disadvantages, always pause the video and take some short notes. Remember, advantages and disadvantages are prone to discussion. We have fiber optic cables. These are made up of glass. That's why they are very expensive. They are made up of glass. Fiber wires zimeundwa na kioo and transmit information in light form. Zina transmit mwangaza. The cable is made up of the core, the central part of the cable, which is made of transparent plastic or glass. Cladding, it is a single protective layer surrounding the core and has some right bending characteristics, reflection. We got a reflection in physics. Then it has a buffer, the outer, the inner circuit surrounding then the jacket. Then we have the types of fiber optic. We have single mode and multi-mode. So single, this one here is showing really displaying a single mode fiber. It has the cladding and the inner core. Then you can see the glass down there. So single mode fiber, it has a very narrow center core. The light in the cable therefore takes only one path through it, making it have a low attenuation. So one advantages of this one is it has low attenuation. Then you have the multi-mode fiber. You can look at it. This one works by reflecting. It has the cladding, the thicker core, and the jacket. So it has a thick core and allows several light layers to be fed in the cable, have a high attenuation rate, and they are mainly used for shorter distance. So when you want to transmit data using fiber optic, always go for the single mode fiber. So from there, you can see the advantages of fiber optic. They are, we said they are very expensive. Disadvantage, broke easily since it's glass. It is difficult to install. It is also complex to configure. But on the other hand, very secure, cover large distances. It is immune to electromagnetic interference and carry high capacity of bandwidth. Then let's go to wireless communication or unbound media, now that we are done with the bound or wired. Here, this communication transmits data from one point to another without physical connections. Example of a wireless transmission. We have talked about microwave, satellite, radio, infrared, and others like Piconet or Bluetooth. The electromagnetic spectrum. This one you can just study it. This is it shows the wavelength and frequencies. We have the radio wave, we have the gamma rays, and ultraviolet rays. This one, for the purpose of understanding, you can just have a talk with your physics teacher about the electromagnetic spectrum. Then let's go to microwave. If you look at the diagram there, we have point-to-point microwave. This means if there is an obstacle between this one, it will block something called line of sight. So these gadgets must face each other. You see, we have building A and building B. We have the dish, microwave dish in building A, facing directly to avoid the line of sight. So in microwave transmission, signals travel in a straight line, and therefore the transmitter and the receiver must be in the same direct line. So that's a disadvantage. They operate at high speed, that's an advantage. They are less prone to errors or other things. They are capable of operating in a digital or analog data. Disadvantages, we have talked about the obstacles. Then we have the satellite. Now the satellite uses the microwave radio signal. It transmits, a satellite must be in a situation whereby we have the downlink transmitting to the space satellite, and then there is a downlink. The downlink now consumes the signals from there. In case you get a situation whereby you are asked to explain the transmission in a satellite, always draw the ground station, the space station, and then we have the uplink and the downlink. The one here transmit upward. This is called an uplink. This one is downlink. This is the satellite in the space. This is the satellite on the ground. That's how the transmission occurs. Now, advantages that is the cost is not dependent on distance. Has the second highest bandwidth after optical. That's the fiber optical cable. Earth station can be installed on a customer property than layering expensive or extensive cables. Disadvantage, any station can receive the signal. It is expensive to install ground stations. Heavy rains or bad weather will increase loss of signal. So we also have VSAT. This is a very small aperture terminus. Also, it's a type of this satellites microwave transmission. So you can see the VSAT, the way the diagram looks there. So the new trends in microwave transmission have seen the use of very small aperture terminal, VSAT technology. This refers to a very small satellite dish used both in data, radio, and TV communication. Many businesses are adopting this new technology because it enables direct access to satellite communication instead of having to go through the satellite owner, satellite gateway. You can see things like we have this installation of Zuku and the others. They use the VSAT. We have radio transmission. You can see an example whereby there is an aerial, that is the antenna. Call it antenna. This one is omnidirection, means one direction. So radio waves travel just like surface water. They are omni. Omni should mean not limited to any direction, not really one direction. Omnipresent, omnidirection. Omni means many. So this one doesn't have apparent direction. It is just transmits anyhow. The information is transmitted, it's scattered, it is broadcasted. That is the best word to use there. So the same applies there. So we have the Bluetooth. You know about the Bluetooth or Piconet. It connects two gadgets with Bluetooth capability. It is also prone to distance, about approximately 40 meters or less. You can just have, it depends on the gadget strength. Then we have infrared. Communication through this media is achieved by having infrared transmitter and receiver, just like you have a television and a remote control. Then, now let's go to the next element of transmission. We have the communication devices. So, computer and transmission media require communication devices that are used as interface or junctions between terminal devices. Data communication media include network interface card, the NIC. This is the part where you insert the internet cable in a computer. You have modems, codecs, hubs, bridges, repeaters, routers, gateways, switches, and points. So this is a router. If you want to access Wi-Fi, that is the wireless fidelity, from a certain other gadgets, you must have this gadget. This is here I can see we have a hub. A hub is a gadget where you insert many cables, then connect them to many computers. A modem, we said, it's a gadget that converts analog to digital signals, just like a codec. Then we have a router. This is a router. You can see it has antennas. These ones are used to transmit the internet brought by a cable to it to wireless gadgets. Then we also have an amplifier called a repeater. When the signal suffers from attenuation, you need to install a repeater station to give it strength to move to the next station. You also have a bridge. If you have two networks, network from building A and network from building B, and you want to read them together, you must install a gadget. It can be a computer or a hub. That one is called a bridge, just like a daraja. It's a network device that selectively determines the appropriate network segment for which a message is meant for delivery. Rather, it is just a gadget used to connect internets from different directions. We also have a gateway. If for example, when you want to connect a network now from the hub to the computer using the UTP cable, you insert it to a port held by a gadget called network interface card. So it is a circuit board that fits inside an expansion slot, a workstation. Okay, it is just a circuit board where you insert your internet cable switch. Now we usually have a gadget called a switch and a hub. It's just more or less than the same thing. The only difference is that the switch forward packets of data directly to the address, but a hub just scattered them. The hub will just broadcast. Then we have wireless communication. When you have a gadget receiving signals wirelessly, we call it access point. You see now, this gadget here, right now, I give you a good example. When you are in a public meeting or in a church or in your school for a meeting, there is this gadget. When you use a microphone, there is a gadget with two antennas that receive the microphone's voice or speech and then transmit it elsewhere. That's an access point. It's just a point where wireless communication is proceeded. Then you have these other gadgets. You can just peruse them. Then let's go to the last part of the elements. We have the network software. This refers to programs that generally manage a network. They include the network operating system, or NOS, NOS, network operating system, and the network protocols. Now, for a computer to talk to another computer, or for a network gadget to talk to another network gadget, there need to be an operating system that supports networking. This operating system is called network operating system. Then for gadget A to communicate with gadget B, they require a rule, Sharia, a rule. This rule is called a protocol. So protocols refers to the rules that make computer gadgets or any communicating gadgets to pass signals. So network operating system, it makes sharing of resources possible, e.g. a printer and a computer. It transmits data around the network. It responds to requests from application programs running on the network. It enables nodes, these are different points on the network, to communicate with each other more efficiently. It's also implement network securities. It ensures that there are firewalls. Firewalls are programs that prevent malicious requests. Then there is supporting network services like network card drivers and protocols. So just like I summarized, a network operating system is responsible for allowing the communication between nodes or between gadgets on a network. Examples, we have Linux, we have Unix, we have Novell NetWare. You also have Windows New Technology, Windows NT, Windows Millennium, and others. We also have Windows 2012 Server, very popular. Protocols. I have explained what is a protocol. These are rules or procedures that are followed by communicating devices. We usually have we have this layer called the OSI model, Open Interconnection Model. This is a procedure. We can talk about a diagram showing how transmission takes place. It usually consists of number 1 to 7. Layer 1 is physical layer. This is where the packets are finally transmitted via network card through the transmission media from the place wherever they are coming from. Then you have the data link layer. This one adds the checking information, prepares data for going onto the physical connection. So then we have the network layer. This is whereby the addresses information is added. Then we have transport layer. The data transfer takes place here. We have session layer. This is where data between communication devices is checked or reset. Then we have formatting and displaying encryption wherever is added in the presentation layer. Then you have the application layer. User applications runs here and generate data transmission or open layer. So we have the 7 layers of the OSI model. You can just check it or read more from other sources. Examples of protocols, the popular protocols are TCP, that is TCP/IP, Transmission Control Protocol / Internet Protocol. It is responsible for delivery of data, that is of sequenced data over the network. Whereas the IP or the Internet Protocol handles the address scheme. It does something called packet forwarding and routing. Then the file exchange, when you want to exchange files from one place to the other, when you're downloading or uploading, what takes place is file transfer protocol. So it just allows the downloading and uploading of files. Then we have network topologies. Every network must be arranged in a certain way. The actual arrangement of gadgets, devices, computers, printers in a network is called topology. So topology refers to the way in which computers and other devices are arranged in a network. Usually consider or view network in 2 ways. You can see network in a logical way, that is the signal way, the way the signal is transmitted, or the way physically, the way venye computers zimepangwa physically, that is the physical topology. So logical topology involves the way data is passed through the gadgets in the network, whereas the physical topology shows the arrangement or the layout of the computer. So examples of logical topologies, that is the way signal is transmitted, we have token ring and Ethernet. Now Ethernet is assumed that before the data is transmitted on a transmission media like a wire, the transmitting gadget resends the cable whether there is another gadget transmitting. If there is, it holds on. If it is free, it sends. Whereas token ring, it is whereby data is packed in a token, in an envelope, and that envelope is marked the address of the owner. So then the token is released on the network. computer A, if computer A gets the token and reads the address, and the address it's not its own, it passes the token to the next available computer. Let's go to physical topology. Physical topology means the arrangement venye zimewekelewa kwa meza. Usually have star, unaweza zipanga kama nyota, star, bus kama basi, ring kama pete, mesh mchanganyiko, pete okay, mesh inamaanisha every gadget is connected to the other. So in mesh, every gadget is connected to the other. So if gadget A fails, still gadget D and E and the others will still send, because it's like a mesh wire. Every wire is connected to the other. Then we have the hierarchy or tree. This is a combination of a star and bus. So let's look at them the way they are. Remember, now look at this one. This is star topology. Computers zimepangwa kama nyota. They are all coming from one place, hub. Hub is a multiport. Port ni hizo mashimo za kuweka wires. So you can put so many. There is 32, 64, 16 and 8, even 4, even 1 you can have. So star topology, all devices are connected to a central hub. Just like you can see. In an exam, you may explain or draw. So advantages of this one is easy to configure, it is easy to expand. One station, if one station fails, it will not affect the others. Then it allows centralization of resources. Disadvantage is that if the hub dies, the whole network is dead. Requires more cables. You buy a lot of cables. Installation of this one is also time consuming. Then we have the ring in a car pete. Every computer is connected to the other computer. So in ring topology, all components are connected in a single cable. So it is simple to install. Data transmission is very fast. Use a short length cable, hence cheap. Disadvantages, one side fails, the whole stuff. It is difficult to troubleshoot. To troubleshoot it is to identify and fix a problem. Also, it's not easy to add because you have to stop the whole network. Look at the mesh. Mesh means every gadget is connected to each other. So you can give the advantages, easy to troubleshoot, not costly because every gadget must be connected, uses a lot of wires. Then this is the bus. This is the hierarchy or tree. We said hierarchy is combination of star and bus topology. So you can see the way they are. Then you can look at the advantages. Then this is the bus. Inakaa kama basi. Devices are connected to a central cable called the backbone or the bus. You can see every gadget. Na kule mwisho you must put things called terminator. They prevent bouncing back of the signals. Kule mwisho unapenye imeandikwa terminator. It can be a printer, it can be a computer or other gadgets to avoid bouncing back of the signal. So bus topology is easy to install, less expensive or cheap rather. If one node fails, others are not affected. Disadvantage, the failure of the cable will bring the whole network down. That's the failure of the backbone. It's also difficult to troubleshoot. Guys, thank you very much for watching. My WhatsApp number is there for purposes of asking for the notes. And also, remember to subscribe. And also remember to comment on my videos. Thank you very much.